Hi friends, welcome to my YouTube channel. This is lecture number 12.1 and in this lecture we will study questions and answers based on transformer construction. So first question is desirable properties of transformer core are. Desirable properties are high permeability, low reluctance, low hysteresis losses. Next question is size of transformer core depends on. We know that EMF equation of transformer is E is equals to 4.44 bmf by A, where bm is the maximum flux density and f is the frequency. So from this equation we can say that size or area of core depends on maximum flux density and frequency. Next question is an iron core transformer has maximum flux density 0.8 Weber per square meter. If core is replaced by silicon steel with flux density 1.2 Weber per square meter, then percentage reduction in volume is. So here this question has been asked in ES 2007 and this question is also based on EMF equation of transformer. So here is the EMF equation of transformer, that is E is equals to 4.44 bmf by A. So from this equation we can say that area A is inversely proportional to the maximum flux density. From this inverse relation we can write A1 by A2 is equals to BM2 by B1, where BM2 is the maximum flux density when core is replaced by silicon steel, where its value is 1.2 Weber per square meter. So BM2 is 1.2 Weber per square meter. BM1 is the initial flux density of iron core, that is 0.8 Weber per square meter. So BM1 is 0.8 Weber per square meter. If we put these values, then we get A1 by A2 is equals to 1.2 by 0.8. So on solving this, we get 33% answer. It means percentage reduction in volume is 33%. Next question is which core is used in high frequency transformer? So ferrite core is used in high frequency transformer. Next is core of transformer are made up of material. We know that transformer core are made up of CRGOS, that is CRGOS, cold rolled grain oriented steel. What is core losses in high frequency ferrite core used in SMPS? So remember this, it is only 1%. If iron core of transformer is replaced by air core, then hysteresis loss will be. See, hysteresis losses are associated with the iron core. Okay, so if we remove the iron core and replace it by air core, then hysteresis losses will become zero. Next question is why transformer core is laminated? We know that transformer cores are laminated to reduce the eddy current loss. Next question is when eddy current losses are reduced, if laminations are thick, if laminations are thin, primary turns decreases, primary turns increases. Here answer is if laminations are thin. Why? Suppose this is unlaminated core. In that case, this is flux density B and this is area enclosed by the eddy current loop. Okay. So why eddy currents are induced? These are induced due to Faraday law of electromagnetic induction. So here you can see that if core is not laminated, then large area is enclosed by the eddy currents. Okay, and the amount of eddy current is directly proportional to the area enclosed by eddy current loop. So here eddy currents are more. But if we laminate the core, okay, made up of thin laminations. So here you can see that if I made this core with these thin laminations, that in that case you can see these eddy currents will get concentrated over a very small area. So if this area enclosed by eddy current loops get reduced, so eddy current also get reduced. Okay, so this is the reason that eddy currents are reduced if laminations are thin. Next question is Buchholz relay is used for. It is used to protect transformer from internal faults. Sludge formation in transformer oil is due to oxidation of transformer oil. This has been asked in ES 2008. Okay. Next question is what is function of transformer oil? This is very simple and very common question. This has been asked in ES 2008, 2003 and 1996 and GATE 1996. So the basic function of transformer oil is insulation and cooling. But there is also a third function of transformer oil, that is transformer oil prevents the oxidation of paper insulation. So this is also function of transformer oil, but main functions are insulation and cooling. Next is why rating of transformer is in kVA not in kilowatt. So this is very important and common interview question. So answer of this question is rating of machine is load which it carries without overheating and insulation damage. Insulation requirement depends on losses. In transformer, copper losses depends on current while core losses depends on voltage, not on power factor. That's why rating of transformer is in VA, not in watt. Next is what is flux density in CRGOS, and that is equals to 1.9 Tesla. Next is mutual coupling between primary and secondary winding is more if cores are cores have low reluctance and high permeability. Next is stepping of core is done to reduce the amount of copper used, and if amount of copper used get reduced, then copper losses will be reduced automatically. Okay. Next is advantage of cell type transformer is. See, advantage of cell type transformer is reduced leakage flux. Why it is so? See, in case of cell type transformer, both the windings are wound on same limb. Here, this is cell type transformer. Okay, so it has three limbs, that is 1, 2 and 3. So these windings are wound on this central limb. Okay, so that's why it has reduced leakage flux. Now next question is which has two magnetic paths, core or cell type transformer? Here answer is cell type transformer. See why. In case of core type transformer, it has two limbs. Okay, these all concept have already been told to you in my previous lectures. So this is core type transformer. Here windings are wound on both the limbs. Okay, it has two limbs only. So here you can see that same flux goes throughout the core. Okay, so flux throughout the core is same, that is equals to 5. So there is no division of flux in the core type transformer, while in case of cell type transformer, here you can see that this is cell type. Suppose flux in central limb is 5. Okay, this is 5. Now this 5 divides in two magnetic paths in the outer two limbs. So flux in outer two limbs will be equals to 5 by 2. Okay, so two magnetic paths are present in case of cell type transformer only. So that's why answer of this question is cell type transformer. Next is hollow tubes stacks, that is used in which part of transformer and why? See, hollow tubes are used only in radiator of transformer, and these hollow tubes forms the radiator, and radiator helps in cooling of transformer oil. So radiator, it provides the increased surface area for cooling of transformer. Sandwiched winding are used in cell type transformer. Eddy current losses are reduced by, first we know that eddy currents are reduced by thin laminations, and second is eddy currents also get reduced by using ferrite core or CRGOS material. Next question is, transformer core laminations are coated with enamel layer for, answer is, insulating laminations from each other. Next is, laminated insulation coated with varnish is a staple adoption in transformer assemblage in order to, answer is, minimize eddy current losses. Next is, how laminated core reduce eddy current losses. This has already been told to you in the in my previous slides, that eddy current losses in core are due to currents produced by alternating field. When iron core is made up of thin laminated sheets, then eddy current break in many parts of a small area. As resistance is inversely proportional to area, so resistance offered by small area to eddy current loops will be more. Hence, eddy current get considerably reduced. So these all are the questions related to the transformer construction. Now I want to ask you a question and you have to answer this question in comment box. So question is, how we can reactivate silica gel, or reactivation of silica gel means making it again blue from pink. Okay, so how we can regain the moisture absorbing capability of silica gel? You have to answer this question in comment box. Okay, so please answer this in comment box. It will help me to understand whether you are getting all my lectures clearly or not. So please answer this question in comment box. This is all about this lecture. I hope you like this lecture. Thank you. Jai Shri Ram.